Hey everyone, welcome to question 10 of the chapter 6 review. In this problem we want to solve the trig equation 2 times the cosine of pi over 6 times t is equal to root 2 for this time the first 4 positive solutions. So to begin with this problem, what we should be doing is cleaning up the trig function that we have before us. So we have 2 times the cosine of pi over 6 times t is equal to root 2. Ideally, since we have this multiplication, we want to clear it so that the trig function is completely alone and cleaned up. So I'm going to divide both sides by 2. That's going to cancel out. And I'm going to be left with the cosine of pi over 6 times t is equal to root 2 over 2. So at this stage in the game, it's really going to depend on you as a learner and you in terms of how you approach your problems. But you might want to, for example, use a u substitution, or sorry, just use a substitution where I'm going to call my variable u in this case. You can use something else if you would prefer. Some people prefer to use a substitution here because it is less overwhelming on the I. So they would rewrite their problem as the cosine of just the variable u is equal to root 2 over 2. So now we should take a step back and kind of say, well, that output looks really familiar. So in this case, we can say, I know that I've seen that from my unit circle. And hopefully you're on the verge of becoming an expert or really proficient with the unit circle to note that one of the angles, for example, would be pi fourths. That would give me a cosine value or a cosine, an output with for a cosine of root 2 over 2. And then you also want to make sure that you've covered all of your bases. So what other quadrant could you possibly get a positive root 2 over 2 when you take the cosine of that angle? And using a different color, we might say, oh, I know that there would be one in the fourth quadrant at 7 pi over 4. So straight away, we have the following solutions. We've gone ahead and we said, well, u could be pi over 4. I also know that u could be 7 pi over 4. But we're not done because, again, we want to have the first 4 positive solutions. So that means that since we've covered all of our bases within the first single revolution of the circle, we need to go around again. So if I use a different color here, and let me go ahead and clean this up so that we can kind of see what I'm talking about. Oop, and I erased part of my 4. That's not good. Put that back. Let's go ahead and clean this out. So we have a fresh canvas to kind of work with. Okay, so we know that we had the 45-degree angle, so that was our initial one. So we can go around and do another full revolution to reach the next angle. So in this case, that would be u is equal to our pi fourths, because again, that is accounting for this first portion of the angle, and then we're going to add another revolution to get back to it. So I'm going to continue. So that's my 2 pi that you're seeing there. So we can clean this up, and that's going to be pi over 4 plus 8 pi over 4, just getting that common denominator. So our other solution would be 9 pi over 4. And then we can continue again. So let me go ahead and, again, clean out my work here, because we had said that we had another angle located here, so at 7 pi over 4, but I can continue it. So I can do another revolution to get back there. So in this case, we would have our 7 pi over 4, and then we're going to add another revolution. So 7 pi over 4 plus 8 pi over 4 is going to give me 15 pi over 4. So as you can see here, we have 1, 2, 3, 4 solutions. So we've satisfied our work. Now at this point, we've done the heavy lifting. We just need to do some adjusting. So I'm going to scroll on down. I'll keep those within view. So we know that u, recall that u is the same thing as pi over 6 times t. So I'm basically just going to go ahead and switch all of these u's that you see out with a pi over 6 times t. So pi over 6 times t is equal to pi over 4. I can hit this with the reciprocal to clear it out and get t alone. And this is going to give me 6 over 4, or in other words, 3 halves. Again, we're going to see the same thing. I would encourage you to maybe pause the video and solve these on your own to see if you get the same solutions as I do. So I'm getting 21 over 2. And then if we do pi over 6 times t is equal to 9 pi over 4, flip that out to cancel it. This becomes a 2, that becomes a 3, so now we have 27 over 2. And lastly, we have pi over 6 times t is equal to 15 pi over 4. Take the reciprocal on both sides. That goes away. The pi's will cancel out. This reduces to a 2. This reduces to a 3. 3 times 15 gives you 45 all over 2. So our solutions are 3 halves, 21 halves, 27 halves, and 45 halves. I hope this video was helpful. If you have any other questions, please feel free to message me in WAMAP, post to the forum, send me an email, make a comment on YouTube. Thank you so much.